Okay, these notes are solution stoichiometry. Okay, solution stoichiometry involves the molarity of a solution. We're going to be doing stoic just like we did with gas stoichiometry. Okay, you're going to do volume to mass and mass to volume. And you're going to have to use the equation. If you remember, in gas stoichiometry, you used the ideal gas law equation. This time you're going to be using the molarity equation because it involves molarity. Okay, volume to mass. Now, to find the moles of a given solution, at this point in time, just like in gas stoich, when you did volume to mass, you had to use the ideal gas law equation first to find the moles. Here, we've got to find the moles by using the molarity. Now, if you remember, this is our little upside down P sign, and there's your molarity is moles per liter. Well, we're looking for moles, which means we are going to be taking the molarity times the liters to get the moles. And this is the moles of our given substance. So you're going to be given an amount, a milliliters or a liters. You're going to be given a volume and a molarity. And using that, you're going to have to find the moles of that particular substance. Now the second step at this point is putting it into a picket fence. So you calculated those moles. So the moles of the given that you calculated go here. And at this point, we're going to use the equation. We're going to get our mole ratio, okay, using the equation. So that's what this step is. This is our molar ratio from the equation, okay, and then that gives us our moles of the unknown, and then this is the step that we're going to put in our molar mass. So this is the other substance that's listed. Okay, this will be the substance in the question where it says, what is the mass of? So, what is the mass of, ... This is your unknown substance. This is what you're trying to calculate. Okay, let's try an example. Okay, so it says, how much magnesium nitrate is produced by the reaction of 500 milliliters of 0.350 molar HNO3. Well, if you remember in the molarity equation, this has to be liters. So we're going to change it to liters. Now our first step is we take the molarity, which is 0.350 molar solution, and 0.500 liters. And I want to see the units in here. It really does help. It lets me know that you know what you're going. Well, it lets me know that you know what you're doing. Okay, so this comes out to be moles of HNO3. Now the second step is where we're going to take our moles, so 0.175 moles of HNO3. Okay, and then we are going to put it in our picket fence. So the next step is moles of the unknown and moles of the given. So we're going to look at our equation. Now, moles of our given is the HNO3, and if you remember, I told you the moles of the unknown is, it says how much. So our unknown is the MgNO3 2. Now we just have to use the equation to find the numbers. So moles of HNO3, 2 and 1. Okay, and that crosses that out. And 1 mole of MgNO3, 2 magnesium nitrate, has a mass of 134.32 grams. That's the thing. Okay, so, and when you do that, you get 11.8 grams of MgNO3, 2. And that is our answer. So it's not too difficult, really. Just remember, you have to calculate the moles by doing the molarity equation, and then you put it in a picket fence. Okay, next is mass to volume. Now, with mass to volume, you're going to be given two substances again, and it's going to ask for how many liters. And that how many liters is your unknown, because you're going to be given a mass. So the first step, oops, that back up there. The first step involves changing that mass to moles by using the picket fence. So we're going to do the mass of the given. So there's going to be a mass attached to a certain substance, and that's your given substance. And then it's 1 mole of your given over the molar mass, because you are trying to find the mass, or the mole, can't talk today. You're trying to find the moles of your given. So at this point in time, you're going to use the equation. This is where your mole ratio comes in. So your moles of given here, and your moles of your unknown go here. I'm going to erase this. This line is way too long. Okay. And this is going to give you your moles of your unknown. Now the second step involves the equation. So let's go back to look at our upside down P sign. And this time we are looking for liters. So liters is moles divided by molarity. So that's what we're going to use here. So we're going to take the moles of the unknown that you just calculated in the step above and divide it by the molarity, and that's going to give you the liters. And remember, your unknown is what it's asking for. So the problem's going to ask for how many liters or how many milliliters or how much volume. Okay, that's your unknown. So let's try an example. Okay, how many liters of 0.5 molar HNO3 is needed to react with 125 grams of MgCl2? Okay, so our first step is 125 grams of MgCl2. Molar mass is 95.12 grams of MgCl2. 1 mole of MgCl2. Okay. Now we're going to use the equation, and it's moles of MgCl2 here and moles of, what are we looking for, HNO3 here. Now remember, this comes from the equation. This is your mole ratio. So MgCl2 is 1, and then this is 2. Okay? And this gives us 2.626 moles of HNO3. Now we're going to take this 2.626 moles and we're going to put it over top of the molarity that's given, which is 0.500 molar. And when you do that calculation, you get 5.25 liters of HNO3. Pretty easy. Hopefully you guys can handle this. There is another type of solution that's volume to volume, but we're going to stick with that when we get to acids and bases, because that's used mainly for titrations. You can use it for this equation. There's actually one extra step. There's another step where you have to change the volume using the molarity equation. So you're using both sets of molarity equations. So I prefer not doing that with this. I'll just stick to titrations with it, so we'll get to that when we get to acids and bases. So you are not quite done with stoichiometry just yet. Sorry guys, but the next unit you also have stoich. Okay, well, this is Monday, or this is the weekend notes, so I guess I will see you on Monday. We'll do a warm-up and then do some problems, and hopefully you guys understand it because the test is Wednesday. See you Monday. Bye.